All right, students, welcome back for our second lecture of Unit 1, where we'll continue where we left off, looking at, this time, thematic maps and closing up with some terminology regarding cartographic communication, or how maps help communicate information to us in the best ways. Remember from the last lecture that maps can kind of be divided into two categories. Reference maps that are about, sort of referring to those maps as sources of information, right? About location and where cities are and road maps or atlases or property lines and those things that we discussed before. And thematic maps, which are the kinds of maps that can be used to tell a story or communicate information. The ones that we're going to examine are the choropleth map, which you can see in the top right, dot distribution maps, graduated symbol or proportional symbol maps, isoline maps, cartograms, and the flow line map in the bottom left. Beginning with choropleth maps, we can talk about the pros and cons of each style of thematic map. For a choropleth map, some of the benefits are that it's relatively easy, most of the time, to collect and map data on these maps, especially when you're displaying data for large areas, right? A state or a county or something like that. And in general, these maps are very common. If you've seen a thematic map before, you've very likely seen a choropleth map. And typically, they're easy to understand. The cons, the downsides of these maps are that they can be dangerous because they can be very general. They can use some of these forms of cartographic communication we'll discuss at the end of the lecture to obscure differences or maybe hide data depending on how it's displayed. And I'll give you an example of that here in a moment. These are some examples of choropleth maps that you can see and the kinds of information you might display with them. The top left, we've got confirmed cases of COVID-19 in the U.S. per 100,000 people. That's kind of a dated map. That one's a little from a few months ago. Spending per student in the top right. For around the country, you can see kind of, in this case, counties throughout the country and how much they're spending per student and how that sort of compares to the national average. You can see our own Clark County there if you look hard in Nevada. The bottom left, I've got a map of development for Africa, and then zoomed in on the state of North Carolina, a similar and older map of per pupil expenditure for education in North Carolina. This is a fun and relevant one. These are the average exam scores by state for the 2018 AP Human Geography test, where you can see those that got a 3 or higher on average throughout the state in the darkest blue, and those that scored the lowest in white there. Again, you see our own Nevada. I'm curious to how that would break down if we could look at it by county. Probably not too much different. Now, this is where we get into what can be dangerous about a choropleth map. The big thing to know here is that all of these maps are showing the same thing. They are all showing the same data. It's just how that data is grouped and classified, right? How it's arranged in order to show colors can make a problem seem non-existent or dramatic, right? Depending on how you distribute that information. So this is something you really need to pay attention to as you examine these kinds of maps. Is that information, is the data sort of evenly distributed? Is it grouped up in these big chunks or what? Dot distribution maps have the benefit, we can see a dot distribution map there, have the benefit of showing how and sometimes even sort of where things are distributed, right? The downside to this is that that's much harder to collect. You need point data, right? You need to know exactly where something happened, where someone was located that got sick, where exactly a McDonald's is in a city, and so on. So in that case, they can be harder to map, and sometimes students will confuse them with the graduated symbol or proportional symbol map. We don't want to do that. These are really neat maps that were produced by, I want to say the University of Virginia a couple years ago. These are dot distribution maps by race, in this case, in the United States, where you can see the key in the bottom left there. But these maps are made, each individual citizen that responded to I believe it was the 2010 census, is mapped here with an individual dot. And then on this map, you were able to zoom in to actual cities and neighborhoods with that census data and see how it mapped out. So you can see Boston and Pittsburgh and Baltimore here, and the ethnic neighborhoods that make those cities up, right? How you can see sort of these ethnically segregated regions of a city, some places more mixed in than others, but other places also pretty segregated, right? Graduated symbol maps or proportional symbol maps is what you might see them as sometime. Has a benefit. All of these are kind of combining graphs with data, but in this case, it's a little bit more intuitive, right? In that the more frequent something is, or the greater degree to which it's occurring in an area, generally you're going to see a larger symbol in that spot. And the less it's happening somewhere, you're going to see a smaller symbol in some spot. And that's pretty easy to understand. The downside is that information is still ambiguous, right? Unlike a dot distribution map, for example, you have no idea where exactly those things are occurring, if it's distributed throughout a state, for example, or if it's concentrated in a particular county or city or something like that. These are some examples of proportional symbols. The one on the left showing you where oil is, right? With the yellow symbols in proportion to how much oil is being produced in certain areas, and the big sort of black hollow circles showing estimated crude oil reserves, right? How much oil is sort of untapped, I guess, underground in those areas. The one on the right there is a proportional symbol map that shows how much land in each state is owned by the federal government, right? Is like BLM land, for example. You'll see that Nevada, as far as percentage of the state, is by far the winner of that category, right? I don't know if that makes us the best or the worst, but it means that the federal government controls a huge chunk of the western United States. Isoline maps, you are probably familiar with. You've probably seen them before, even if you haven't used that term isoline map before, okay? ISO means equal. So this just means sort of lines of equal value, right? What you will see is that if you have a lot of these lines together, that is indicating very rapid change, okay? It might mean that elevation is changing very quickly, or temperature is changing rapidly, or rainfall or air pressure, depends on what's sort of being shown by the map, but that rapid change is occurring when those lines are close together. When you see these lines spread farther apart, it means that the change is slower or gradual, or the landscape might be flat. If there are cons, right, those aren't really pros, what I mentioned to you, but if there are downsides for this map, it's that it's very limited in what you're going to use it for, right? It's hard to represent all kinds of data with an isoline map, and very often you'll see it used really just for like temperature or pressure, air pressure, elevation, things like that. So here you see in the bottom right, that is a topographic map, right? Where you see isolines of equal value. In this case, the equal value is the elevation, right? The other ones you can see are variously showing temperature and cloud systems and air pressure and things like that. But these are isoline maps. One of the things to keep in mind is that when these maps are referring to temperature, they will call the lines themselves isotherms, right? If you're looking at temperature, sort of climate related maps, they'll be referred to as isotherms instead of isolines. Cartogram maps are real fun, really neat ways of combining graphs with maps, right? Integrating data onto a map in a way that makes it very easy to visualize differences and compare those differences across areas. Again, the downside here is that it can be overly simplified and sometimes kind of ambiguous in what exactly you're seeing. But you can get some neat things here. Okay, this is a world map of organic agriculture where countries have been distorted in size based on how many hectares, which is about close to 2.5 acres of land that are devoted to organic agriculture, right? So you can see someplace like Australia, which does a lot of organic agriculture, is gigantic. And a lot of Africa, which is just trying to, in some cases, grow enough food to feed their population, is not overly concerned with fancy things like organic agriculture right now. More often than not, if you've seen a cartogram, you've probably seen a population cartogram, all right? And this distorts the size and shape of countries based on their population, okay? So the greater the population of a country, the greater the size of that country on this map, right? So you see China and India are the largest. Bangladesh, which is a tiny place, really, it ends up being very big on this map. And so, yeah, right, this is a very easy way to kind of visualize which countries are biggest in terms of population and which ones are not. These are fun. Cartograms showing the distribution of some of America's favorite companies here, right? Walmart, McDonald's, and Starbucks. And how you might see them distributed across the country. And you see it's not quite the same in each one, right? It looks like you've got a stronger Starbucks presence on the West Coast. Maybe there's more McDonald's relative to the Starbucks in the kind of northern, Great Lakes areas. Interesting to look at. Flowline maps are the last kind of thematic map we're going to look at, and these maps use lines of varying thicknesses to show the volume or the amount, and the general sort of direction might not be the right word, but the movement of a particular phenomenon, all right? So the one that you'll see a lot is something like this, right, which is the example I had on the previous slide as well. You might show migrations with a flowline map or the movement of goods, right, like through trade. The downside here is that it's ambiguous, right? This shows us, based on the thickness of the line, how many immigrants are coming from which areas, right? So based on the thickness of that line, you can see that our largest migrant flows are from North America, right? From Central America, from Canada, and from Asia. But it's not really clear where these people are going, right? They're not going to Colorado and Kansas and things like that, right? These lines are just pointing to the center of the country, right? But this is overlaid, you can see, with a choropleth map, where it shows the percentage of immigrants per state, right? So you can kind of combine maps sometimes to get better representations of data. But the flowline map is just the part where it's showing lines running from one part of the world to another, right? To show generally the amount of movement and the general sort of direction of that movement. Now, another way we can kind of look at this and think about the differences in how these maps might be more or less useful in displaying data is to kind of examine the process through which it might be applied. All right. So if we take a data set like these are presidential declarations of disaster areas by state from the 1950s until 2010. All right. And they're arranged in alphabetical order here, not necessarily in the order of the states that had the most disasters or anything, right? If you did that, you might plot it out like this, where you can visually kind of see the states that had the most presidential declarations of disaster and the ones that had the least. But then when you start to plot this is what that same data set would look like on a dot distribution map, right? And if you counted them up, it should match pretty closely, right? You've got a small amount in Utah, and apparently we're going to have the largest amount in California. And then the advantage here is that we can see sort of, ideally, if this is accurate, where those natural disasters occurred and be a little bit more accurate with that information, right? In how a state might want to distribute resources and things like that, for example. Proportional symbols might be easier or quicker to interpret, right? It's real obvious which places have the most declarations of disasters and which places have the fewest, but this may or may not be less useful to you than the dot distribution map, right? Depending on what you're trying to tell. And then a choropleth map is another way to display it all together, where, again, you get a real obvious idea of which places are having the most declarations of disaster, which places are having the fewest, but not really any sense of where exactly that stuff is going down. And for the last part of this lecture, we will look at a couple terms that you're going to read more about in one of the articles you've been assigned for homework. Cartographic communication, right? Or how maps communicate information to us in ways that make them easy to understand and reduce clutter and excess, right? How you actually sort of turn a picture, I guess, of the Earth into a map. One of the ways that maps communicate information is through simplification, okay? And that is very simply, all right, simplifying what you're showing on the map, removing all the excess information that is not relevant to what you're trying to portray, right? So if I'm trying to show you the main highways through a city, it's not necessary for me to have all the surface street junctures that those connect to, or the locations of churches, or bodies of water, or parking lots, or schools, or track and field locations. Any of that stuff you might see on the left map, a lot of that I can edit out, and I can simplify that map to the one you see on the right that just shows very generally and simply the main highways for a particular location, right? So simplification. Symbolization is exactly what it sounds like, right? Representing data on a map using symbols, okay? So that you can plot that and maybe have several things that you're looking at in relation to one another. This is a famous map made by a man, John Snow, actually, as one of the kind of earliest attempts at sort of layering maps together. In this case, you've got symbols for water pumps throughout this area of London, I believe, and symbols for cholera victims, all right? And what this man was able to show by making this map is that there was a connection between this bad water pump that had become contaminated with sewage water in one section of the city and the cholera outbreak that was taking place there. In this case, you're using two different symbols to help communicate that data. So symbolization, when you see a symbol for an ambulance or a school or a bus stop or something like that on a map, that map is using symbolization. Classification is something that takes place, for example, here like on a choropleth map. Classification is the grouping of data, okay? So let's say you wanted to show population across the United States like this. Well, you could do that with a dot density map, perhaps, right? Each dot represents 1,000 people or something. You could do it with a choropleth map. But in order to do that very simply, so that you don't have to have 1,000 different symbols or 1,000,000 different symbols for the population of every little city, you can classify that data into categories, right? You can chunk it together in such a way that it's easier to display. You might also imagine maybe seeing a map that has different symbols maybe for different sized cities, right? The biggest cities, 1,000,000 or more people, might be a big red circle or something like that. And the cities that are 100,000 to 500,000 people might be a smaller symbol, right? And the cities that are 10,000 people or less might be a different symbol altogether. You know, instead of having to represent a lot of symbols to show all the different populations, you could chunk them into groups and then have just a few symbols to represent those classifications, all right? So the classification of data is another means of cartographic communication to help maps communicate their information more effectively. Induction is maybe a confusing one, all right, but it is when a cartographer displays more information on a map than was present in the original data set. Okay, and so this map is showing arithmetic density, or the amount of people per square kilometer. Well, you might imagine that there was not a geographer or surveyor or interviewer that went to every square kilometer of a country and counted up the people, right? That's not how they figure that out. What they did do is they have the total land area of a country, and they know the total population of a country, and they map it out like this and give you a very rough idea of about how many people there might be per square kilometer. When in fact, we know that some parts of these countries are going to actually have much higher densities per square kilometer, like a city or a city center, right? And some areas are going to have nobody living in them at all, right? Like the big stretch between, the first cities in California and Las Vegas, right? You drive through hundreds of miles of desert where the population per square kilometer is almost nothing. A few other ones that you won't really see in your article, but which are relevant to some of the maps you might see, are ideas like rotation, right? Rotating parts of the earth to either orient north in a certain direction or maybe orient certain buildings or certain countries at the top of the map instead. People often like to joke that you could represent the southern hemisphere at the top of the map and the northern hemisphere at the bottom of the map, right? Because like we mentioned in the last lecture, the Earth is in fact not a flat rectangle. It is a floating globe in space that has no up or down or top or bottom really in space, right? Where's the top of space? Where's the bottom of space? It doesn't exist. So there's not exactly a top or bottom, of the planet, regardless of what we choose to call north or south. You can kind of show anything on the top or the bottom of the map as long as you let people know you've rotated it from what they normally expect. Another thing you might see that varies between maps and how maps might be conveying information to you is what they've chosen to locate at the center. Okay, these are two different maps made, both of them by National Geographic. One centered on kind of the Pacific area or East Asia, and one centered more typically around sort of the prime meridian, right? And Africa and Europe. There's even been some wonky ones that have tried to place the Americas in the center where you end up with other cartographic issues, all right? So that's a silly one to leave us on. That concludes our second lecture where we have discussed the various types of thematic maps you might see and where I've tried to explain some of the different kinds of methods used in cartographic communication and how maps try to simplify or extrapolate data in such a way that makes it easier for us to understand. Thanks a lot, guys, and talk to you again soon.